All right, guys, let's get started. Okay, so we are current. Okay, we don't expect. Give a sec. All right, so hopefully it's working. Okay, so let's get started. We are currently on week 11. Okay, so we're getting very close to the end of the semester. So week 16 is the last week, right? Presentations. And then we've got a finals week. So we've got 11, 12, 13, 14, and 15. So we've got about 5 weeks left. I'll remind you that next week, week 12, is exam 2. So on Tuesday, okay? So it'll be similar to exam 1. It's comprehensive. Okay, so that means everything we've covered from the beginning of the semester until basically this week. It's closed notes, but you're allowed your cheat sheet, 8.5 by 11. Any questions about the exam? All right, so that'll be next, so it'll be Tuesday, okay? So a week from today. So don't forget, you need to attend class, of course, take the exam here, obviously, right? All that. And yeah. So, and it's, as I said, covers everything. All right, so we've covered a lot of topics throughout the semester, so I'll kind of do a review of that. I've graded most of your assignments. I think I'm just one assignment behind. Okay. All right, so let's go to content. Close these. All right, so we've covered so far introduction to Linux topics, services and tools, task scheduling and cron, network packets and SCAPI, DNS, account management, host-based firewalls, Hadoop, and yeah, so those are some of the basic topics. That Hadoop was the last one, basically. Okay, so today we're going to start SNMP. This is should be a week or 2 lab or topic. So I'll go over this in the slides. And then you can see here we have exam number 2 coming in. Okay, so this should be a nice topic. It's still kind of in the same scope, but it has to do with network monitoring on a now on a more broad basis with a protocol. All right, so I'm going to go ahead and start that. So I have some slides here. Wait, should be this one, SNMP. All right, so I have a Word doc, of course, as usual. So we'll go over how SNMP works in Linux, basically what it is, where it comes from. And then I have some slides for this. So this does have more theory, given that it's a bigger type of a protocol. So we'll talk about that. Okay, so let me download the slides. Okay, and I will open the Word doc. Okay. So let's go ahead. Slides. All right. Click on the enable here. All right. So have you guys heard of SNMP? Basically, never covered it anywhere. No? Heard of it? All right. So yeah. So this is an old protocol. Actually, it's been around for a long time. It's still it's one of those things that it's still around, but companies will try to sell you products related to it. Okay, so like Microsoft would have it available in Windows Server, for instance, and then they didn't have it available in Windows Server, and instead, what did you have to do? You have to like buy it, so it's kind of like that. It's an important thing because it's not really used by us, right? Like normal people on our normal computers. This is a corporate type of a thing. So a company will use SNMP. Okay. So it's basically related to server. Obviously, there's a version, it's a protocol. So it's like the internet, right? That your internet can run on Mac, or your web browser, can run on, the HTML can run on Mac, Windows, Linux, etc. So it's the same here with SNMP. It's meant to be a protocol that will run anywhere, right? And so there's open source, like in the Linux environment of SNMP, and then there's going to be, really the protocol should be available on Windows, etc. But because it's more for corporate and, they can tune it and specialize it for various things, I have seen it in the past where it's a product that they, as an add-on that you sell. But anyway, it's a very interesting thing. We've done a little, it kind of goes back to some of the things that we've been doing this semester, which is basically automation, collecting data from computers, right, by running our scripts. So you guys, we've done uptime, these kinds of commands, and gotten data, right, locally, basically, through scripts. But there is, in fact, a protocol that does exactly that. All right, and it's called, as you can see in the name, the Simple Network Management Protocol. Okay, so kind of a networking protocol, and it ties into this course, of course, as this is a sysadmin course. But this is more for like a network. All right, so the lab today, or this week, will be basically 2 VMs, and we're gonna, put them in SNMP. So similar to what you did with DNS. So hopefully you see the theme, right? So with DNS, we had 2 computers, and one would use the other, the client-server architecture. Then with Hadoop, you're building a cluster, etc. And now with SNMP, you're also going to create this group of computers where you have managed computers and management computers, okay? So, but the lab is just, you need to have the 2 VMs basically and configure them kind of in the same architecture. That's the lab, the Word document that you saw a second ago is basically what, we will do for the lab assignment, and I'll show you how to configure SNMP. It's pretty straightforward, actually, much easier, I would say, than DNS or anything else, okay? But today I'll start with some of the theory. There's also a way, because this is a protocol, you can actually access this via Python, or other scripting languages. So I will also show examples of that. In fact, you could build your own application. I may not cover that, but I will show you some of the specifics. All right, so the idea is basically, kind of to motivate this, we're going to think now bigger, right? Bigger than just one computer. And we're going to create this thing called the NOC, the Network Operations Center. All right, so we're going to think of that as, you guys work in an NOC, so it's full of screens and computers. And basically, what are you doing there? You're just monitoring everything. You're making sure that everything runs, right? And you're keeping statistics and running reports, for instance. Okay, that's what SNMP can do for you. So most machines will have some kind of a way of supporting SNMP, okay? And so we're going to talk about that. So what if you create new computers like the Internet of Things computers, right? And you also want to monitor those. Well, because it's a protocol, it's open for that as well, but you would have to design certain things, all right? So that's kind of what we're going to talk about today. All right, so, Cisco devices, that printer, a router, a firewall, etc., will support SNMP so that you can monitor them. And of course, as usual in this course, we're going to talk about security, and basically, you'll probably see very quickly that SNMP can be a very dangerous protocol as well. So you want to be aware of the security implications of that. All right, so what is network management? Basically, basic tasks that fall under this category are configuration management, fault management, and performance management. It's a configuration management, just keeping track of device settings and how they function, right? So you believe it or not, every computer in the network, you can query it via SNMP and ask it, the value of thousands of variables, and those variables then are things that, like how many bytes were sent out of this interface, things like that, right? So you can basically, there's no limit because you can always, the way that it's built is you can take one definition and expand it even, okay? Yeah, as long as you follow certain rules of how you do this configuration. So that's what we're, discussing. But right now, so it can be used for configuration management, for fault management, so dealing with problems and emergencies in the network, such as a router stops routing, right? So what happens if, if a router fails? Well, the idea is that SNMP could, send you information about that. There's a specific way of communicating called a trap that SNMP uses for such a thing. Okay, and so we'll explore those things today. Server losses, loses power, etc. So all this, that's one of the reasons why SNMP was designed. Performance management would be another one. So basically, as an IT person, you want to do like statistics of how the systems are running. That's actually the part that you will do for your lab assignment. Okay, so I will demo how it works, and then I'll give you like a problem or two that you have to basically address. Okay. So how smoothly is the network running? Can I handle the workload it currently has? Okay. So functional areas of network management. So as I said, configuration management. So this is basically configurations, inventory, fault management examples, reactive and proactive network fault management, performance management, collecting things like number of packets dropped, timeouts, errors, you name it. There's a lot. Security management, SNMP is not for security, all right? It wasn't designed for security. It's actually, if anything, adds a layer of insecurity, okay? So it's not meant to be used over the internet. It's meant to be used, internally, basically, okay? Cost management, it can be used as an accounting system to keep track of resources, justify new expenses, etc. Asset management, similar. And planning management, also similar. Analysis of trends to help justify a network upgrade or bandwidth increase. The nice thing about this is that this is a protocol that already exists, so you don't have to like build this part. You really just collect the data, and then you can run reports and things like that. Okay. Any questions so far? Making sense? Pretty simple, right? All right, so what is SNMP? Some formal definitions. So like I said, like, TCP, right? And SSL, various things like that. It's basically a protocol. So it's a tool, a protocol that allows for remote and local management of items on the network, including servers, workstations, routers, switches, and other managed devices. It's comprised, basically, the terminology is to have agents and managers. So you start to see kind of a pattern, right? Always have some devices that manage, other devices that are managed, basically. So the agent process running on each managed node, collecting information about the devices running on. So this is what we will do this week, probably on Thursday. We'll configure the client. We've seen several examples of doing this semester. And then we'll configure one manager. So one CVM, 2 Linux machines. And basically, we're going to collect data of it. But if you had a Windows server or something like that, you could add that in as well. You can have as many Linux machines as you want, etc., or other devices even. The thing is, you have to install the SNMP client protocol on that device so that that device can speak to an SNMP manager, basically. And of course, there's got to be some agreement You know, there is some security, although it is not very secure, in fact. The manager is the process running on a management workstation that requests information about devices on the network, basically. Okay, advantages of using SNMP. It's a protocol. That's really the advantage. So standardized, universally supported. You know, Cisco comes with this. As I said, Windows Server should come with this, or they're charging for it now. Extendable, which is one of the things we'll kind of look at, although that's not part of the lab, but I will give you some intuition as to how you know, let's say one example is if you were an Internet of Things vendor, right? You might want to include SNMP, so how would you do that, right? So there's several layers, basically. It's like an onion, so it's got a very basic, the networking communication via UDP, and then you can add several other layers to add more functionality. It's portable, allows distributed management access, and it should be a lightweight protocol, although some network management you know, protocols do add a lot of traffic to the network. Think about it. It's a lot of little packets, right, from all these computers coming in. It's UDP, so it doesn't have doesn't need a TCP handshake or anything like that, because it's not critical per se, right? But it's still, there is a burden to the network, so just keep that in mind. And it might be in one of your Wireshark reading assignments, you know, where it talks a little bit more about this. Okay. SNMP exposes management data, and it's very simple. It's actually just, you know, I can really just describe it like this. We did the SCAPI one, right? So we did SCAPI. If you remember, we can craft a packet. So just craft a UDP packet, and then in there you'll add a special type of a header, right? That's going to be an SNMP header, and the SNMP header basically has a command like ask this question, which is basically like get, and then the variable, you know, get some data. So everything is variables in this protocol. So, you know, you have that printer, and that printer has interfaces, and those interfaces have variables associated with them. And I mean variables like in programming type of things, right? So it'll be like the variable will have a specific number that's very unique, right, to that model. So there's no confusion. And then it'll have a name associated with it, and of course a value, right? So like the number of bytes that interface has sent out. Okay, that value is stored, so that can be queried via one UDP packet back to the manager, and then the manager will process it. That's the basic idea of it. So SNMP exposes management data. Variables on the managed systems describe the system configuration. And these variables can be queried and sometimes set by managing applications. So there is the option of setting, which is basically writing, but hopefully you realize that is probably very dangerous, right? If somebody takes over, you know, something like that, a computer, imagine if they can write all these variables of all the computers in your network, that's probably not a good thing. So might be a good recommendation to have the functionality of writing disabled, you know, but you use this for monitoring, so you definitely can read, and that shouldn't be such a big issue. There is some cryptography in one of the versions of SNMP, version 3. We'll be using version 2 in this lab, so it's not going to be encrypted, but it's meant to be network traffic within the company, so it's not being exposed to the internet. So overview and basic concepts. SNMP agents show data of interest on the managed systems. Okay. Variables can be things like, you know, how much free memory is available. What is the system name, right? That's one of the easiest things to query. And a lot of this lab will involve just querying things. Number of running processes, right, that you might have, default route, etc. Now, the list can be very big, okay? You can have, as I said, thousands of variables associated with the machine. So variables accessible via SNMP are organized in hierarchies. Okay, so that's really the thing. It's like a tree. Okay, these hierarchies and other metadata are described by the management information basis. So this is what this is called. And this is a good solution because there is, in fact, the SNMP communications protocol, right? And that's a separate thing from these MIBs. The idea being that SNMP works, right? But you can specify these MIBs based on your company. So these MIBs can be specific to Dell, for instance. Dell computers might have their own MIBs, which basically means Dell computers will have their own definition of the variables that can be queried for their system via SNMP. But everyone, like, you know, Dell, Hewlett Packard, etc., will use the same underlying SNMP protocols, and then each one will have their own specific MIBs. Okay, so their definitions. So we'll take a look at that. All right, so the SNMP protocol, in its most basic form, a packet is sent to a network device, okay, such as a router, with a question called a GET. All right, so that's basically it's not a very complex protocol. It just has these basic commands, like, you know, what is a GET is get a variable. So for example, one might ask, what is the value of IF, which means interface, MIB, interface out, octet, and then 1. So basically, that's the variable that's being queried, okay? So usually you can query by these variables, or you can query by the specific number, which is a very long number, okay? And we will see some examples of that. So basically what this means is, if you notice, there's like a hierarchy here, right? In that there's interfaces, and then out interfaces, and then octets, and then number 1 or 2 or 3. So everything is organized in a tree like that from some root origin, similar to how DNS worked, right? And the file system, so similar idea. The variable is in the group interface, okay? The router then will reply with a packet containing the value for this variable. There are variables for just about everything and every kind of technology. And like I said, this is, you know, the vendor can specify whatever they want. There are some basic templates. So for instance, in your lab assignment this week, you will just take the Linux default template, and you can just use that, for instance, for Ubuntu, right? You know, I'll show you guys how to use that. So SNMP overview, defined mechanism for remote management of network devices, okay? The fundamental principle, all device management is done by simple variable value manipulation, okay? So it's a protocol for requesting, returning, notifying of changes of values, basically, and keeping track of things. So this is an example. So you can have basically a host computer. Notice that there's basically an SNMP management station. This could be like a server. And then this is the network, of course. And within this network, you have a printer. And the printer is connected to the network. So therefore, it can have SNMP as a protocol. A host machine, like one of the machines you're using. You can also have a router and any other kind of device. Let's say it's a Cisco router. So then you go to Cisco command line and you say enable SNMP. You establish some of the security, and that's it. And you can now query that machine. Very simple, right? Very straightforward. And what's important is this router is Cisco. This is a Linux computer. This printer is Hewlett Packard. Here's a Windows computer, tons of servers and things like that. Internet of Things devices, all of it can be collected and displayed in the management workstation. Make sense? Okay, yeah, so it's a nice protocol, very interesting. So here's, we'll do this on the VM when I switch to that a little later today, and when I start doing the demo. But just to give you some background right now, so basically this is just a shell. So you do something called an SNMP walk. Okay, so this is on a machine. You can query the same machine like yourself, or you can query another machine. But if you do that, you have to establish the security first. Like there's something like a password thing, and that will allow you to communicate with other machines. So here, the idea is you do an SNMP walk on the command line. The -C stands for community string, in fact. And this community string is actually the password, okay? The word public there is literally the password. So keep that in mind. So like if you code it that it's public. -V1 means the version. So it could be version 1, version 2, version 3. Version 3 is the one that has cryptography and everything. Remember that when you add cryptography to anything in the network, that's a higher burden, right? More overhead, because now you have packets that are encrypted, traffic needs to be unencrypted and all of that. All the devices now need to send encrypted packages with packets, which means that they need to do the encryption. Okay? Or you can do it without encryption. And then basically this is just some server called 45 csstevens.edu. So that's the machine that you're querying. And as long as you've established that this machine by IP address can query it and you provide the correct string, it'll, basically return information. So what does it return in this case? Because you're doing an SNMP walk, basically it's going to return all the variables. Okay? So that's what an SNMP walk means. You don't specify a single variable, so you're going to walk the whole MIB of stevens.edu, and let's assume it's some kind of a Linux server. So in this case, notice it's saying SNMP version 2 MIB system description, and basically it says, it's a jet direct. I don't know what that is, but maybe a printer. Okay. So it's providing that information. It's got some object ID. You can start to see the numbering. And then it starts giving you variables such as system uptime instance. You see that? So there's the uptime yet again, right? But this time you can get the uptime via SNMP. Okay. All right. So anyway, we'll do this. This is like the hello world of SNMP. So it'll be one of the first things we will do once we've configured the client. It's not difficult to set up an SNMP client on Linux. All right, so basically the nodes, items in an SNMP network are called nodes. There are different types of nodes, managed nodes, management nodes, and nodes that are not manageable by SNMP. So then, some legacy systems probably. Okay. Here's another diagram. So you have a manager there. You can have other managers as long as you've established who can be a manager, and the password, you should be okay. Here you have agents such as, routers, a server basically, etc. Just anything in the network, and you can query it basically. All right, I'll skip this proxy part. All right, so what are the 4 basic operations in SNMP? They are get, next, set, and trap. Okay, that's basically like a nice exam type question I like to ask all the time. So I will probably ask you one of these, like what is one of these? So get is the most basic one, is like a read, retrieves the value of a MIB variable stored on the agent machine. So this could be an integer, a string, or address to another MIB variable. Get next retrieves the next value of the next lexical MIB variable. So this is more of an iterative. It's meant to be like efficient. Set changes the value of an MIB variable. So if you notice, this one is where I was saying could be dangerous, okay? Because, you can set variables of your machines remotely, right? So that's, something that happens. And this protocol lets you do that, but, it can be a little bit not recommended. Trap is an unsolicited notification sent by an agent to a management application. Basically, this is, or typically, it's a notification of something unexpected, like an error, okay? So that's when you have that router that has two power supplies and one of the power supplies failed, right? So you don't want the other one because it might be like a very important router for the whole, company. And so you would definitely want SNMP at that point to issue a trap and just say, hey, one of the power sources went out. So that is accomplished via trap in the SNMP protocol. Okay, and here's an example. Traps are unrequested event reports that are sent to a management system by an SNMP agent. Remember, it's literally just a packet, a UDP packet, right, with everything that it needs in the protocol. We will look at that in a second, just to kind of get a feel for how that would work, but it's pretty efficient. Yeah, so traps are unrequested event reports that are sent to a management system by an SNMP agent process. When a trappable event occurs, a trap message is generated by the agent and is sent to a trap destination, a specific, network address, basically. Many events can be configured to signal a trap, like cable fault, falling NIC card or hard drive, or a general protection fault, etc. Right? So, or a power supply failure, which is the example that I said. So all of these things can be configured, right? Traps can also be throttled. You can limit the number of traps sent per second from this agent. Remember that this is very customizable. That's the whole idea. And there's a difference actually between SNMP and the thing that can collect the data, right? So we will see in the lab this week, we're going to use an open source tool called Cacti, which should help us to basically be like the collector of SNMP information. And that's so you guys could go into business, for instance, and create your own Cacti, if you will, and use SNMP in the background. You guys see that? So that's kind of the idea. All right. Traps have a priority associated with them. So similar to like intrusion detection systems, right? So you can say critical, major, minor, warning, et cetera. And that way it helps you to organize, because if you imagine you're managing a big company or something, you might have a lot of traps, a lot of computers. So, all right, trap receivers. Traps are received by a management application like Cacti or something, some server. Management application, it's basically based on the port numbers. So you will see in a little bit that the idea is that the manager that opens a port, right? It's going to be a UDP port, and it's listening on that for traps. Management applications can handle the trap in a few ways. Pull the agent and send the trap for more information about the event. Log the reception of the trap, completely ignore the trap. All right, and then management applications can then be configured. This is where like you pay for products like this and can send you a voicemail, email, etc., using the SNMP data to notify. So there's a lot of vendors that do this. Spiceworks, I think, is one example of it. An open source type of thing. All right, management components. So we're going to get into some of the components of it. To do management tasks, SNMP uses two other protocols called the Structure of Management Information, SMI, and the Management Information Base. So this we're not going to do in the lab, so I'm not going to spend too much time on it. But basically is what I was saying. It's like there's SNMP, and then there's a couple of things on top of an SNMP that are the things that companies, that develop tools like Cacti, or people or companies like Hewlett-Packard that want to develop new network devices that have MIBs, right? So they'll use SMI and MIB to define those. So it's almost like a syntax in a programming language, or if you want to think of it like JSON or something like that, right? This is an older protocol, so it's got its own approach, this SMI, but I would describe it almost as a JSON that was done back then. All right, so the architecture and model, we can think of it in like an organizational model, information model, communication model, and functional model. So it's just different ways of thinking or looking at aspects of SNMP. Okay. So the organizational model just has to do with the relationship between the agents and the nodes. The informational model has to do with these MIBs and the SMI, right? And additional this ASN1 syntax. So it's all the ways in which you define, the variables to be queried for SNMP. And then the communication model basically has to do with the transfer syntax, and security aspects, UDP protocol, etc. Okay. So let me. Right, so here's an example of how it all works, right? So let's say you're going to send an SNMP operation, like a packet. So you have an agent, right, that's going to define what variables it wants to query, right? So you got the variables. But these variables are defined via using SMI rules to describe these variables. It's like a programming language, if you will, right? Like the syntax. And then that is used to create the data structure, which is called the MIB of all the variables that can be queried. And then that can be converted into the packet, basically, the sequence of bytes that's going to be transmitted, okay? But this is the basic idea. All right, so that's kind of the same graph. This is, I want to mention this. So this is basically, it's a hierarchical data structure. So remember, you're going to have, different objects, and we'll see in a second that they have specific numbers that are assigned based on this hierarchical structure. Okay. So the MIB. So here we have an example of that. You can see it, I think. Yeah. So basically, this starts with, 1361. So this was created at the very beginning of SNMP, and it just indicates like the root of it, right? That never changes, right? That's very specific. But then you go into management, because you could also have private, experimental, and other things. And then, so it's usually going to be 1.3.6.1.2 and then MIB1, okay? And then from there, it starts to go into the different things like system interfaces, ICMP, UDP, and so on, right? So this is how it's a hierarchical data structure until the leaves of this are going to be the actual variables, okay? But this is how just by looking at an ID, everything about it. You know which variable it is, what computer it belongs to, what company it belongs to, and so on. Right? And this is how all the variables need to be organized, basically. Okay, and there are private MIBs as well. So 1361 private, and then you got Cisco, Hewlett-Packard, 3Com, and so on. Okay. All right, so we've mentioned this. We talked about that. Here's a nice graph that kind of gives you an idea. So SMI is like the language syntax, right, for the definition. The MIB is then where you define the data structures. And then finally, you have SNMP that's using all of that in the background, okay? You build the whole application. Well, here's an example of the flow of it. So you have number of UDP. So you want to know what is the number of UDP user datagrams received, right? That's the manager. Okay, so the manager then will have to use this structure, right, to query. So basically, SMI defines that it's integer values, right? Then the MIB defines that it's an object that has an integer value and is called UDP in datagram, right? And that means UDP's in, and with an ID 1361.2.1710, okay? Because that's in the structure, and if I go back to this one, right? So it's 1361.2.1, and then I think it's interfaces, so 2. Do you see that? So that's how you organize all the variables. Does that make sense? Any questions about that? All right. So yeah, so that's why, you know, people can just decide, well, I'm Hewlett Packard, so I'm 13614, and then whatever Hewlett Packard is, I think it's like 11, right? And from there, they can define, okay, this is servers, this is routers, this is printers, so that's another number. And then from there, the specific models, and then the individual variables. And all the information is contained in these IDs. Active Directory, by the way, on the Windows side, works in a very similar way. Okay, this is like a very standard way of organizing all these variables. All right, anyway, so let's continue with this demo here. So the demo, the manager then, you know, as I said, wants to query UDP in datagrams, right? So that's 136121710, right? 10. Yeah. So we'll do an example. Actually, I think one of the homework problems is I'll give you some Python code because you'll be using SNMP, and I will ask you to query some variables. So how do you do that, right? So, you need to know this ID or the name of the variable for Linux specifically, right? So I'll give you some examples of that. All right, and then finally, once you know what you're going to ask for, everything is going to be encapsulated. So the request is going to be encapsulated in a SNMP packet, a GET request packet, basically. So then the packet is ready now, and SNMP sends it out into the network. And you can see it goes out. The SNMP packet is a GET request, goes to the agent, right? The agent is configured to respond, right? Okay. Oh, wait, sorry, I clicked the wrong button. Yeah, and then now it's going to respond another SNMP packet with the response to the manager, and that's it. I mean, this protocol is pretty straightforward. All right. All right, so we talked about that. Management information basis. Just don't forget that's the organization of the variables. So I can skip this part. Here's an example of how example portion of an MIB and how things are defined. Notice, the interface is group. Then you specify, you have to say that you have like these data structures, right? Like object type, syntax, keywords that allow you to define new entries into your MIB, basically. Okay. Okay, and we've talked about this. So actually everything starts at root, then ISO, then org, then DOD. So that's the 1361, right? So it's iso.org.dod.internet, basically. And this just probably goes back to the days of DARPA, right? ARPA, where the whole internet came to be. All right, so that's basically the organization of it. Okay, so these are examples of how to set it up. All right, so this part is kind of important. So just quickly, the packet, basically the UDP packet, basic message format is going to have a message length, message version, the community string, which as I said is the password, the PDU header, right, and then the PDU body, and this is the SNMP protocol data unit, right? So when you're creating this packet, it's going to have this information. Probably with Scapy, although I have not tried this, and I'm not going to assign it as a homework, you might explore creating SNMP packets, right? That might be a fun thing for you to try. Okay, here's an example of the communication via UDP of all the possible communications. So remember, you have a SNMP manager and an SNMP agent. So this would be probably like a laptop or something, and this is just it's a web server, Linux web server. So then the SNMP via UDP can do GET request, GET next request, GET bulk request, and a set request. Remember, that's when you change the variable. The SNMP agent will provide either a response, which is a solicited or a trap, which is, an unsolicited. So this is when there's a fault and it just issues something that, like I said, that the power source went down. And then between managers, SNMP managers can communicate to do an information request or provide reports, etc. as well, so that they can sync up. Okay. This is just, how the data can be encoded in bytes, basically. So you can take a look at that. All right, you can see here, basically, this is the OSI model, and then just, some of the same communication, but in the OSI representation. All right, we're going to talk a little bit about security here, because this you'll definitely need to do the configuration. So SNMP communities define communities specifying access to specific variable sets. All right, so that will be one of the key things. You have to specify like the network ID of the managers on an agent, basically. And you need to specify the permissions like read, write. So I'll switch to the Word doc in a bit, and this I'll reference once again. And then you need to provide this community, which is the password in the message. Okay. Here's an example. The port numbers are 161 and 162. SNMP messages are 161. So SNMP uses user datagram protocol, UDP, as the transport mechanism for SNMP messages. You can see you've got your Ethernet frame, your IP frame, a UDP, and then SNMP message, basically. Okay. So messages use UDP ports, 161 for requests and responses and 162 for notifications. Okay, so we've talked about that. You can see that there. The trap, the server sends it to the client. And we've talked about this, so some of the functionality of it. So versions of SNMP for the lab, I think we'll be using version 2, but you can try other versions if you'd like. Basically, it's just historical. Okay, so the initial version 1 is the initial implementation. It was criticized for its poor security. Authentication of clients is performed only by a community string, in effect, a type of password. SNMP was approved based on a belief that it was an interim protocol needed for taking steps toward large-scale development of the internet. It can be the de facto network management protocol if you would like to use it. Version 2, SNMP v2, it's a revised version of v1. It's got improvements in areas of performance, security, confidentiality, and management to manager communication, basically. The new security system in SNMP2 was not widely accepted. It was viewed as overly complex, right? So it's been an evolving thing over time. There's versioning issues. SNMP v3 provides important security features, message integrity to ensure the packet has not been tampered with. So that can be achieved through cryptography, authentication, encryption of packets, etc. Right? So basically more security. So SNMP, which is true, a lot of vendors develop around it. SNMP implementations vary across platform vendors. SNMP is often added feature, not an element of the core design, as in Windows Server, for instance. SNMP's tree structure and linear indexing may not always interact well with the internal data structures of the platform. This one I mentioned already, using SNMP to query certain data sets may result in high CPU utilization. So it can have a burden on the systems and the network. Some organizations might usually want to have a separate network for the management, in fact, right? They'll have separate lines, et cetera, to move that traffic that way, but it's still initially initiating from some of the devices, so it can cause problems. Okay, so this just talks about some of the common problems. You might want to explore those. Okay. All right, so here now I'm done with the slides. So this is an example of, I don't know which device this is, but this is kind of how it works, right? You can see here, we'll do something similar to this one, although not this one. You'll have some application. Notice that here you have the OIDs, right? Those OIDs are basically variables, right? And it specifies what they are. So you have system uptime right there, system contact, system name, interface, and so on. So notice some are strings and some are integers. So for instance, here is just a system description, Cisco internetworking display, operating system software. Yeah, it's just some example. Anyway, so it provides information about one specific device. So really, you're going to have one device, which is up here, I think. I can't really read on mine, but it says Catalyst. Oh, so it's a switch, right? So you have a switch there. At the top, the community string, the general OID, and then all the variables associated with that. Does that make sense, guys? So you'll have an application, a manager using SNMP, and then you're going to set up what devices it can query by IP address, and then basically it'll create some interface like this. And then once you have that information, you can do things such as this one. You can create reports, you can create these graphs. So you saw this in the first Wireshark lab, right? So now you're going to do this kind of again to see trends, etc. And that this is actually your lab problem for this week, is to collect data and create these graphs. But Cacti should do that for you, okay? Keep in mind, so for the lab, you know, you need to collect data for at least an hour or two. So that's actually, I'll give you most of it, but really what's you have to do is run it for a little while. So don't just give it 10 minutes and say it doesn't work. You need to give it enough time to capture data. All right, and here's another example of tools that use SNMP data for things like generating reports, etc. Okay. So SNMP, so in summary, kind of in conclusion, SNMP is a protocol to define a framework for network management tasks. So, you know, there is a nice protocol for this. Many other protocols will copy SNMP's original ideas because it does meet some of the important things like trying to be lightweight, etc. By itself, it's just a definition, right? And must be made real by products. Okay, so it's that even, you know, Windows or Microsoft, you know, develops products around this. All right, so that's basically the slides. So remember, this topic will be on the exam, and it's finished at this point, I think. So I'm going to close these slides, and hopefully we're still recording. It's giving me this. Let's switch. Let me start this again. Hopefully everything was recorded. I'm not sure. Okay, let me I'm gonna restart this.